Hello students, and welcome to another video. Today we're going to be discussing balancing equations. Okay, so here's a vocab word. You've got to write this down in your notes. Okay, as we go through, we drew a lot of these notes in class. I'm just doing a discussion with you that you missed. If you want to draw these pictures as we go, you can, but I'm just going to go for it. So the law of conservation of mass is a fundamental law of nature that states that matter is conserved. Okay, which means that during a chemical reaction, the mass of products is always equal to the mass of the reactant. So in essence, the atoms are just being shifted around. They're not being destroyed. They're not disappearing. They're not sulfur is not turning into oxygen. We're not taking substances and making new substances out of them, like in the sense that we're changing that oxygen into something else. It's just they're being shifted around. So for example, when we look at a bicycle, we have a frame, we have wheels, we have a handlebar, pedals, and that forms a bicycle. And if you look at the bicycle, it has two wheels. It has handlebars, it has two pedals, it has one frame. And if you look here, it's written as that. One frame, two wheels, handlebar, and two pedals, right? That's what makes a bike. And if you notice, nothing was lost. It just got reshaped into one thing, and that's what we call a bike. Okay. Now, let's scroll down here. Okay, now this is the balanced reaction, because we know that bikes have two wheels, at least for the most part. I mean, there's tricycles out there, but tri is three, right? And then it's got two pedals. Okay, now let's go over here and use a example that we use in class. Let's start here. So here's another vocab word you gotta know, and it's coefficient. Okay, to balance a chemical equation, first write the skeleton equation. Numbers in front of terms are called coefficients, right? We added a coefficient to this example over here. Do you notice how there's two wheels instead of just one wheel, right? Because up here is just a wheel. It was just showing you the parts from the skeleton equation. But now we're trying to balance the equation, so we added a coefficient of 2 here, okay? So when we look at this first example, we're going to have carbon and oxygen, and it forms carbon dioxide. And down below, you're going to have to write these out when we do examples. And I'll show you as we go through, okay? So one carbon is going to react with two oxygens to form carbon dioxide gas, okay? If we look here, we have one carbon, two oxygens, two oxygens. This one's a pretty easy one. It's already basically given to us. But if we look down here, this is an example we had in the previous video, the hydrogens and oxygens forming water, it's not balanced, because if we look here, there's two hydrogens and there's two hydrogens. But look here, we have only two oxygens, and on this side, we only have one oxygen. We have an imbalance that's happening. We need to find a way to balance it out, and that's why we add coefficients. So if we look down here, how we balance this, I'll write it down right here. I'll write it with you. So we have H2 gas plus O2 gas, and it's forming getting ahead of myself. We'll add it later, H2O, and that's going to be a liquid. All right, and generally you have to add heat to this equation, right? We did this actually in class. We lit a balloon with hydrogen, oxygen, and it exploded, kind of basically a bomb of sorts, and formed water. But if you look here, we have two oxygens and one oxygen and two hydrogens. So our hydrogens are equal to each other, but our oxygens are not equal. So we got to balance it out. So we got to add coefficients, and this takes practice. You got to play with it to get it to balance. So in order to counteract this, we need to add 2. Okay, I crossed it out earlier, but now I'm adding it. Okay, we have 2 oxygens and there's 2 oxygens. So these are happy now. But now our hydrogens are off, because there's 4 over here and there's 2 over here. But can we make 2 into 4? Certainly. So we have 2 of these compounds now. So we have 4 hydrogens and 4 hydrogens. And now we're balanced. So basically the equation is going to have 2 hydrogen molecules, okay, 1 oxygen molecule, and it's going to form 2 molecules of water. Now if we go down here, here's that balanced equation. Same, but in model form, right? Now we've added 2 of these. We have 1 of those, because we didn't change that. We just had to change this to form 2 waters. And now it's balanced. This equation is going to take us places, because we understand how much we need of the reactants to form these products. Okay, learning the balance equations. It's not going away anytime soon, so you have to get good at this. The practice packet is going to have lots of practice questions for you to work on throughout, and you're going to need it in the next unit when we talk about stoichiometry. So just keep that in mind. Okay. Ooh, lights just went out. That's as far as we want to go anyway. So thanks for watching.